Good evening everyone. My name is Shakira. Today we're going to talk about simple harmonic motion. What is simple harmonic motion? Simple harmonic motion is a type of periodic oscillation where the restoring force is directly proportional to the displacement from an equilibrium position and always directed towards that position. In short, simple harmonic motion only happens when the object has a restoring force that directly proportional to the displacement from an equilibrium position. Later on, I'll give some example for us to understand. But now, let's recognize first the necessary condition for an object to undergo simple harmonic motion. First, there must be a restoring force. There must be a restoring force acting on the object. This force always directs the object back towards its equilibrium position. In simple terms, a restoring force is a force that acts to bring an object back to its equilibrium position. For example, let's just imagine a spring. When you stretch or compress it, the spring force pulls and push it back to its original length. Second, proportionality. The restoring force must be directly proportional to the displacement of the object from its equilibrium position. The restoring force must be directly proportional to the displacement of the object from its equilibrium position. This means the farther you move the object from its restoring force, the stronger the restoring force becomes. It's mathematically expressed as F equals negative kx, where F is the restoring force and k is the spring constant and the x is the displacement from equilibrium. The negative sign indicates the force opposes the displacement. Third, equilibrium position. Equilibrium position is a stable equilibrium position. It requires this is a point where the object expresses no net force that absent on the displacements. In simple terms, the equilibrium position is the place where an object naturally likes to be. It is a spot where its at rest feels no push or pull in any directions. Negligible friction. For ideal simple harmonic motion, frictional force must be negligible. In real-world scenario, some damping reducing an amplitude may occur due to friction, but for the motion to be considered simple harmonic motion, this damping should be minimal. It more simple. Let's just imagine a swing. In a perfect world, ideal of simple harmonic motion, if you give it a push, it will swing back and forth forever without stopping. But in reality, the swing slows down and eventually stops because of the friction. For something to be considered simple harmonic motion, the slowing down has to be very small. For example, a block is attached to a horizontal spring on a frictionless surface where k is 100 and x is displacement from the spring natural length. Let's find the acceleration when the block is displaced by 0.2 meters from equilibrium. The mass of the block is 2 kg. So the given is 100 Newton and 0.2 meters and 2 kg. First step, we're going to use Hooke's law, which is the formula is F equals negative kx. We're going to substitute the value, which is 100. Negative 100 times 0.2 equals equals negative 20 Newton. The negative sign means the force is directed towards the equilibrium position, exactly what is required for simple harmonic motion. And for the second step, we're going to use Newton's second law, which is the formula is F equals ma. So 20 Newton divided by 2 is equals to negative 10 millimeter per second squared. The force is in conclusion, the force is directly proportional to the displacement and directed towards the equilibrium. At x of 0.2 meters, the block experienced an acceleration of negative 10 millimeters per second squared towards the center.